Hello and welcome back everyone. In this session, we will take a look into what is meant by the degrees of freedom. Degrees of freedom is by far the most important topic in design and analysis. In order to get the feeling of degrees of freedom, we must observe the various mechanisms working around us. Let us take the example of door rotating about its hinges. Here I have only 1 degree of freedom, which is rotation about the hinges. So like this only, the understanding of degrees of freedom will be developed while we are working on the projects. But if I have to define the degrees of freedom, then it is simply defined as the number of independent variables required in order to completely constrain the motion of an object. This is the straightforward definition of degrees of freedom in mechanics. If I have to link this definition with the CAE or with the analysis, then we can say degree of freedom is simply variable that we are intent to solve. In CAE, typically degree of freedom depends upon two things. First is the type of analysis we are going to perform, and the second is the type of element. In this session, we will talk about how the type of analysis affects the degrees of freedom, and in the later session, we will talk about how the choice of element affects the degrees of freedom. Since as of now we have not talked about the element, we will keep the second point for the later section. Now let us discuss how the type of analysis affects the degrees of freedom. Depending upon the type of analysis we are going to perform, the independent variables will change. Let us assume that we are performing the structural analysis. Then we have the displacement and the rotation as an independent variable or the degrees of freedom. So here in case of structural analysis, we will have the 3 translation degrees of freedom and 3 rotational degrees of freedom. In similar way, let us assume that we are performing the thermal analysis. Then typically in case of thermal analysis, we only have 1 degree of freedom or 1 independent variable, which is the temperature for which we are going to solve the analysis. As discussed, these independent variables are very important because the software or the tool will solve all the equation for the independent variable in order to get the solution. Since in our course we are going to talk about the structural analysis, mostly we will consider the displacement and the rotation as a degrees of freedom. So in that case, if I consider any object in the space, then generally it has the 6 degrees of freedom to completely define its position or completely constrain the position. These degrees of freedom are nothing but 3 translation and 3 rotational degrees of freedom along the XYZ and about the XYZ. Now let us have a look on these 6 degrees of freedom with the help of NXCAD. Of course, in our sessions we are not going to learn about the NXCAD. But since I want you to visualize how these degrees of freedom work, I am going to show the motion of the object in the NXCAD. You can see on my screen I have this simple object, or you can consider this object as a particle also. I want to see in how many directions it can be freely moved. As you can see, here we have X direction, Y direction and Z direction. This object can be translated along the X direction. So this will be our first degrees of freedom. In similar manner, the same object can be translated along the Y direction. So that will be our second or Y degree of freedom. Again, in the same manner, the same object can be translated along the Z direction like this. So again, this will be our third degree of freedom. So in CAE, typically X means first degree of freedom, Y means second degree of freedom and Z means third degree of freedom. Same goes for the rotation also. If my object is rotating about the X-axis, that will be our fourth degree of freedom. So here this is my X-axis. If I have to rotate about X-axis, I can just grab the handle and you can see the X-axis is stationary and the object is rotating about X-axis. Now let us have the look onto the 5th degree of freedom, which is rotation about the Y-axis. So this will be our Y-axis and it will look something like this. And last we have the 6th degree of freedom, which is rotation about Z-axis. So you can see this is my Z-axis and now we have the rotation about it. I can simply rotate the object like this. So these are nothing but the degrees of freedom for this object. So always remember, in most of the CAE software, first 3 degrees of freedom, that is degree of freedom 1, 2, 3, are nothing but the translation along the X, Y, Z respectively, and degree of freedom 4th, 5th and 6th are nothing but the rotation about X, Y, Z respectively. Now let us understand the same concept of degrees of freedom using the coordinate system. Now here I have the x coordinate, y coordinate and z coordinate. Now keep in mind, this xyz notation is arbitrary. What I mean by the arbitrary is that instead of z, over here you can say this is my x coordinate. So this notation is completely up to you. As discussed previously, along the x I have the first translation degree of freedom. Along the y I have the second degree of freedom, which is translation along the y. And along the z I have third degree of freedom, which is translation along the z direction. Fourth degree of freedom is nothing but the rotation about x-axis. Fifth degree of freedom is nothing but rotation about y-axis, and similarly the sixth degree of freedom is nothing but rotation about z-axis. Just to tell you how important the concept of degree of freedom is, here I have the two problems. As you can see, in both the images I have the beam. On the left hand side I have fixed both the end of the beam in all degrees of freedom. So here you can say that we are trying to simulate the fixed beam. While on the right hand side I have constraint in 1, 2, 3, 4 and 5th direction. That means the end of the beam can freely rotate about the z direction. Just to check the impact of this boundary condition, let me quickly show you how the end results are looking like. Keep in mind, as of now, don't worry about the post processor. Just try to observe what is the impact of the boundary condition. On the left hand side, I have the results for the fixed beam or the beam where we have constraint in all degrees of freedom. While on the right hand side, I have the results for the simply supported beam where z direction is free. If I see the results of displacement, you can see in case of fixed beam, I have the displacement of 0.04 mm. While in case of simply supported beam, I have the displacement of 0.19 mm. Such a massive difference is coming because of just 1 degree of freedom. So again, you must understand the importance of the degrees of freedom. Now just to understand, let us take another example. In this example, we will try to understand the typical setup for abuse type of loading condition. In this analysis, what we are trying to do is that we will fix those locations where the door is connected to the BIW through the hinges, and at this location we will apply the load. In door sag analysis, what we are trying to simulate is that door is open and some occupant is trying to push the door in the downward direction. Now here we will approach the problem in the conservative manner. For example, at this location we will apply the load, but at the same time we will apply the boundary condition in such a way that it will constrain all the rotation degrees of freedom. Over here we will basically tell the hypermesh that this particular point will not be able to translate along the x and along the y direction, neither it can rotate about any of the direction. That means whenever person will try to push the door should not be moved in any direction except z direction, and that will be the conservative load. Because see, we have to be conservative in order to simulate the abuse type of loading condition. By the way, this type of crazy loading and boundary condition are called as an abuse load cases. Think about this, if we free this point along the x and y and about the x and y, then because of the load, door can simply move, so that the stresses would be less and our design will always be safe. So on contrary to that, we will say, you know what, this door cannot move in x and y direction, neither it can rotate about any of the direction. Only possible displacement is in the z direction. So to understand this type of boundary condition, one must understand the concept of degrees of freedom in order to become the good CAE engineer or good CAE analyst. Of course, throughout our course, we will be talking about the boundary condition in multiple occasions. As of now, I hope you understand the overall concept of degrees of freedom. We will meet in the next session. Till then, take care, goodbye.